Alright, last problem. Going to be very, very quick. For a given triangle, angle A measures 60 degrees, side C measures 5 root 3 centimeters. What a weird number. What are the possible measures of side A so that the resulting triangle fits the following descriptions? And let's totally show our work here. Because this is a non-calculator problem, we know enough about the unit circle to solve this without a calculator. So remember, for this problem, first thing we need to do is figure out what is that perpendicular distance right there, because we are going to call that distance the minimum for A. So let's find that. Remember, that's just going to be 5 root 3, that value we know, times the sine of that angle. Well, what do we know is the value of sine of 60 degrees? 60 degrees is pi over 3. Sine of pi over 3, we know that value from the unit circle. Sine of pi over 3, which is the same as sine of 60, is the square root of 3 over 2. And so we can simplify this. Square root of 3 times the square root of 3 gives us a 3. So really what we're dealing with is a 5 times a 3 divided by a 2, which we know as 15 halves. And I don't care if you write it as 7.5 or 15 halves, I'm leaving mine as 15 halves. So, for the triangle to not exist, we would need A to be less than 15 halves. For the triangle to be right, we would need A to equal 15 halves. For there to be exactly one obtuse triangle, we would need A to be greater than or equal to that side we know, 5 times the square root of 3. And for two triangles to exist, we need A to be smack dab in the middle, has to be greater than that 15 halves, but it has to be less than that 5 root 3. If it's in that sweet zone, we will get two triangles. Those are our values, and we are done. Sorry, we're finished. We're not done. We're finished. I think that's proper. Proper.